Hello everybody, I would like to welcome you to our 27th video in the pre-algebra playlist, and in this video we're going to go over the concept of properties of exponents. So before we begin, let's just do a quick review of what exponents are. If you have something such as a to the power of x, where a is one number and x is either the same number as a or some another number, x is what is known as the exponent itself. And we covered this before, that the a is known as the base. So if you have something such as 2 to the power of 5, this is the same thing as saying 2 times 2 times 2 times 2 times 2. Because I'm multiplying my base by itself 5 times, because 5 is the exponent. But now let's say I want you to evaluate the numerical expression 3 to the power of 6 times 3 to the power of 8. Now, one way you can evaluate this is that you can multiply 3 by itself 6 times, find that product, then you can figure out what 3 multiplied to itself 8 times is, find that product, and then multiply these two products together and find your answer. But experience tells you that that will take a lot of time. So what is a quicker and more efficient way of evaluating this numerical expression over here? In order to evaluate this over here, we need to refer to a few properties regarding the multiplication of exponents. So what are the multiplication properties of exponents? Well, it's quite simple actually. If you have some exponent such as a to the power of b, and to that you're multiplying the exponent a to the power of c, then another way of writing this product over here is to simply add up the exponents and keep the base the same. Basically, a to the power of b plus c is the same thing as saying a to the power of b times a to the power of c. Now this holds true for all positive integers b and c. Let's say you have something such as 2 to the power of 6 times 2 to the power of 3. In this case, I can simply evaluate this using the multiplication properties of exponents. One thing to remember is that these multiplication properties of exponents only apply when the bases for all of the exponents are the same. So in this case, I can simply add up the exponents together and keep the base the same. So 2 to the power of 6 times 2 to the power of 3 is the same thing as saying 2 to the power of 6 plus 3. And another way of writing 2 to the power of 6 plus 3 is simply saying 2 to the power of 9. For example, if we evaluated 2 to the power of 6 times 2 to the power of 3 the long way, we would write down the number 2 being multiplied to itself 6 times. And to that, I will end up multiplying the number 2 by itself 3 more times. So now, what I need to do is figure out how many 2's I have. So I have 6 over here and 3 over here. That gives me a total of 9 2's over here. Most cases, this answer over here will be an acceptable form. In this example over here, I have a to the power of 6 times b to the power of 3 times a to the power of 2 times b to the power of 4 times a to the power of 5 times b to the power of 8. Now, if this seems really complicated to you, well, don't worry a lot about it because we'll just take it step by step. Now, in this example over here, we have not one base, but we have two different bases. We have the base of a and we have the base of b. So the first thing that we need to do is put all the bases of b's together and put all the bases of a together. And now I can break this solution into two parts. First, I need to evaluate this over here with all the bases being the variable a, and then I can evaluate all the bases being b over here. So how do I deal with three exponents? So pretty much, I can expand the multiplication properties of exponents into however many exponents I have. If I have something such as a to the power of b times a to the power of c times a to the power of d, this is the same thing as saying a to the power of b plus c plus d. So in this case, I keep my variable a as the base, and simply I add up all of the powers together. So 6 plus 2 will give me an 8, and 8 plus 5 will give me a 13. Now to that, I'm multiplying whatever the value of the expression with the b's will be. In this case, I keep the variable b as the base again, and now all I really need to do is add up all of the numbers of the exponents. So 3 plus 4 will give me a 7, and 7 plus 8 will give me a 15. So my final answer to this big expression over here is simply a to the power of 13 times b to the power of 15. The power of a power property is again quite simple. If you have something such as a to the power of b, and you're raising this whole exponent term to another power of c, this right here is the same thing as saying a to the power of b times c. And again, this works out for all integers b and c. So what do I mean by this? Well, let's just do a few examples. Let's say I have something such as 4 to the power of 3, and that whole exponent is being raised to the power of 2, then this right here is the same thing as saying 4 to the power of 3 times 2. And that is the same thing as saying 4 to the power of 6. To verify this, let's do it the long way. 4 to the power of 3 is the same thing as saying multiplying the number 4 by itself 3 times. And when I raise this numerical expression to the power of 2, that is the same thing as saying this over here. So twice I am multiplying 4 by itself 3 times, which basically translates into multiplying 4 by itself 6 times. Now let's say I had something such as a to the power of 2, and that whole thing is being raised to the power of -9. So all I really need to do is keep my base the same and refer back to the power of a power property of exponents, and note that I can simply multiply the 2 and the -9 together to give me my final exponent. So when I do a to the power of 2 times -9, I will get a to the power of -18. So this right here is my answer when I evaluate a to the power of 2 raised to the power of -9. If I have something such as 2 to the power of 2, that is being raised to the power of 3, and that is being raised to the power of 4, I can first evaluate the inside. So I can evaluate 2 raised to the power of 2 raised to the power of 3. That is the same thing as saying 2 to the power of 2 times 3. And that is the same thing as saying 2 to the power of 6. Now I can raise 2 to the power of 6 to the power of 4. And when I do that, I get 2 to the power of 6 times 4. And that is the same thing as saying 2 to the power of 24. Now let's go over one more property of exponents, and that is helpful when we're dividing exponents with the same base. So the division property of exponents is again quite simple. If you have some number such as a to the power of b, and you divide that exponent by the number a to the power of c, that is the same thing as saying a to the power of b minus c. And this holds true for all integers b and c. Now we can rewrite this using the fraction bar like this over here. Let's say I have -3 raised to the power of 6 divided by -3 raised to the power of -3. So in this case, it doesn't really matter what my base is. All I really need to do is keep my base the same. Now I can refer back to the division property of exponents, and with the help of that property, I can evaluate this numerical expression over here by simply doing 6 minus -3. When I further evaluate this, I get -3 raised to the power of 6 plus 3. And that is the same thing as saying -3 raised to the power of 9. So this right here is my answer. In this example over here, I first need to realize that I'm dealing with two different bases. One of the base is the number 10 and the other base is the variable x. Let's just evaluate the number 10 as the base first. When dealing with the base of number 10, I realize that I have an exponent of a number 4 on the top and only a 1 on the bottom. Therefore, that is the same thing as saying 10 to the power of 4 divided by 10, and that is the same thing as saying 10 to the power of 4 minus 1, and that is the same thing as saying 10 to the power of 3. Similarly, I have the variable x to the power of 2 divided by x to the power of 3. That is the same thing as saying x to the power of 2 minus 3, and that is the same thing as saying x to the power of -1. Now all I really need to do is multiply this over here with this over here to give me my final answer of 10 to the power of 3 times x to the negative 1. I can rewrite this more properly like this over here. Now let me just go over a quick key concept and then that'll be it for this video. Well, so far in your exponent life, you have dealt with exponents being a positive number, a negative number, but what happens when you have an exponent with the number 0? So how would you go on about evaluating 2 to the power of 0? Well, one key concept when dealing with exponents is that whenever you have an exponent of the number 0, the whole numerical expression or a variable expression, basically, no matter what the base is, will equal 1. So if I have something such as b to the power of 0, that is the same thing as saying 1. If I have 100,000 raised to the power of 0, that is the same thing as saying 1. Anything raised to the power of 0 is the same thing as saying 1. Now there is, however, one exception. 0 raised to the power of 0 is undefined. But I am absolutely positive that you will not need to worry about this until later on in your math careers. So that's it for this video. I hope you keep on working hard and I'll see you in the next video.